All right, we are to activity 8. How are you feeling? Ooh, scared, new stuff. So as I mentioned in class, that now we are given a rate, which is a derivative. That's after this little squirrely looking thing. We are given a rate and we're wanting to find the original function. So this little squirrely looking thing is called an integral sign. And we use the shortcut, so you want to have this somewhere in front of you while you are doing these. So based on the shortcut, and in fact if I just get it wrong, it will tell me what the shortcut is right here. And so the shortcut says to take the exponent, and I'm going to do a forward slash to get a fraction, but you can do it in the little box below, and add 1, and then add 1 below, and then do plus C. Be sure it's a capital C. Be sure you have no spaces. If it won't count it right, you know, for some weird reason, because you see I put spaces, just completely clear everything out, and then try to type it in again. But those are some of the issues I see students have. They'll have spaces, so that should be another power rule. Again, if you don't remember these, just miss it and it'll show. So notice that the K in this case is the 3. So I think this would be negative 1/3 cosine 3x. The inside stays the same, plus C. Because if you think about it, that 3 coming out here is the chain rule backwards, right? Because if you did the chain rule, it would be 3. And so we have to divide it out. All right, that's an E, so be sure you remember those rules. This one, probably what I would do is I'd bring that 1/3 out front first. Let me get it wrong so you can see the formula here. So I'd bring the 1/3 out first, and then notice this 3 is the K. So the 1/3 is out front, but then 1/3 again. So 3x plus C. Because I pulled this 3 out front, 1/3, and then this 3 became 1 over K, and 1/3 times 1/3 was 1/9. This one, I think the only problem that students have with this is not putting the absolute value. So, you know, once again, the 1 over X, so I can put the 1/3 out front, and then I can do ln, open parentheses. Took me a while to find that. Open the, what do we call that, absolute value bars, and then plus C. So you just need to be careful that you have it in the correct format. And then this is kind of for you to go through to figure out how you would take the derivative. Oh, and that tells you the answer. And then I want you to watch this video, and then you answer which one you can relate to the most, and then you fill some information out when you submit your answer, and then you have an application. So this is probably the most important thing, because once you get the shortcuts down, you're going to go straight into applications. And so this means we are finding the antiderivative of this. Okay, because it says it grows at a rate. This is the rate, this is the derivative. We want to find the original function. Okay, so what we're trying to find is the antiderivative of this. And I don't know if there is any more thing there. No, please don't put that in there. So explain your thinking. I pretty much just told you everything. Okay, and so now here what you're trying to do, and you can actually type INTEGRAL, and when I hit L, watch what happens. So that's kind of cool. And then 5,000 over the square root of T dt. Remember, this dt is the width of the rectangle, and this is going to 0. So when you find the antiderivative, that will actually go away. So what I probably would do with this is bring that 5,000 out front, and so you have the integral of 1 over the square root of T dt. And then probably what I would do next, I mean, this might be too many steps for some of y'all, but this is just how I see to do it. And then I know that is T to the 1/2 power, right, the square root. And did not mean to click outside there. And so then from here, I probably 5,000 integral. I would bring that to the top, which makes it a negative. And now you have something that the 5,000 is just still out front. Now you have something you can use the power rule. All right, so I'll leave it up to you and you'll know if you get this answer right. And it kind of walks you through, I guess, this step. Okay, it's just finding the antiderivative, and then now it walks you through, well, suppose that when t equals 1, the population is 25,000. So what this means is when time equals 1, the population is 25,000, and now we can come back when we got our antiderivative and solve for c. And then you'll do that, you'll solve for c. When you made it this far, because this is kind of showing you the answer, how many days will it take for the population to reach 115,000? So guess what? You're going to set P of t equal to 115,000 and solve for t. Be careful when you solve this, and once again, you'll know if and when you get it, you got it right. This is what I was explaining in class. Remember, we only looked at this side right here, and now what we want to do is we want to start using this integral, okay? And the first step is to find the antiderivative, and then you're going to see the next step is to plug in our interval, okay, in there. And so that's what this slide, in fact, you're going to come back on this slide. You know, you can see I can add, play around with it and add number of rectangles based on this function. And so that's what this is saying here, the function that is actually graphed. And that's where we're going. So we don't have any more rectangles. We want to get this smooth area. So this right here is still a rate. It is still a derivative. You want to find the antiderivative, and then we're going to plug in these endpoints. Okay, so you're going to plug in 0, and then you're going to plug in 2. That's where we're actually going with this. So same thing here. Integral from 0 to 2 of 12x squared plus 1. I didn't put the parentheses, you don't really need it. And so the first step is to find the antiderivative. Well, wouldn't it just be that and then that, because the derivative of x is 1. And of course you can make this 4x cubed. And then now what you're going to do is you're going to plug in 2 for x, and then you're going to plug in 0 for x. And that's this whole f of b minus f of a, where you plug in the top value, and the top value will always be the larger value, and you will get an actual numeric answer. So do that. This right here, if I actually plug in that function plus 1, and this is the one you're going to come back to, and I put in, what was it, 0 and 2, so you can see this is the area on those last slides that you just did. And do not mess with any of this. Do not mess with any of this. The only thing you're going to do is type in your function and change your a and b. You should have gotten 34 on the previous step. If you didn't, you need to redo it and see that you understand how to get that. All right, and then this just kind of tells you which one was a fixed or a growth mindset. And my work here is done.